Hey everybody, it's Ms. Phoebus, and this is Lesson 25, Point Slope Form of Linear Equations. Now I know this is brand new, so we're going to go through this, and we're going to do several examples, but this is point slope form, brand new. You know slope-intercept, you've done standard form, and now it's point slope form. So let's see what we can do with these. We are doing point slope form that looks like y minus y1 equals m parentheses x minus x1, close your parentheses. So that is definitely something that you are going to want to have handy when you're taking a quiz, when you're taking a test, anything like that. You want to make sure that you have that handy. It emphasizes the slope and a point that is not the y-intercept, but it could be. Most of the time, though, they're not going to give you the y-intercept when they ask you to write point slope form. All right, so we're graphing linear functions still. We're rewriting equations so that we could get them into slope-intercept form from point slope form, and then we are going to write a function in point slope form given a relationship between two quantities. So again, that goes into creating equations, graphing linear functions, constructing functions, that kind of thing. All right, so here we go. Here is our equation. Looks scary, but you've actually seen it before when you look at your slope formula. So if you look at m equals y2 minus y1 over x2 minus x1, and if I wrapped this denominator in parentheses, and then I multiplied by x sub 2 minus x sub 1 on both sides, this would cancel with this, and you would have m parentheses x sub 2 minus x sub 1 equals y sub 2 minus y sub 1, which looks exactly like what we have here in the big font, but there aren't any 2's. We're missing these guys here and here. So it is a little bit different, and I'll tell you the reason why we don't have those 2's is because those are always going to be x and y. So we're going to replace slope, or we're going to put slope in the m spot. x1 is going to be the x part from a point. y1 is going to be the y part from the point, and then the y and the x are just the y and x that are always in y equals mx plus b, ax plus by equals c. There were always x's and y's, so that's where the x and the y go, the ones that are just by themselves. So we're going to identify the point and the slope for each of these. And that is something that you need to do when you graph. When you go to graph these, I'm writing graph. When you go to graph these, you need to know what point and what slope you're going to be working with. So for the slope, I usually do that one first. I'm looking what's in front of the parentheses. So for number 1, the slope is 4. For number 2, right here, there's a negative, but that's implied that it's a negative 1. Remember, you don't always have to write 1 when you're writing it in front of a variable, or in this case, a set of parentheses. All right? The point is going to come from the x part is hanging out with x, the y part is hanging out with y. So when you do this, there's supposed to be negatives in your actual what's going on in there. But when you are actually trying to figure out what number it is, you're going to do the opposite. So you're going to take the opposite of whatever you see and the opposite of whatever you see here. So we're going to change signs. So because I see a positive 8 and they're hanging out with x, it's going to be a negative 8 as the point. And I see a positive 2 hanging out with y, the opposite of that is negative 2. So it's all about opposites when you're pulling those pieces out, and then when you're plugging them back in and creating those equations, it'll end up turning into its opposite as well. All right, so the point, there's my x. The opposite of positive 7 is negative 7. Here's my y. The opposite of negative 9 is positive 9. So you're identifying the point, you're identifying the slope, and you need to do that in order to graph. So here is how you graph. You're going to find and plot the point, and then you're going to use the slope that you've identified to graph additional points. So let's look at what we've got. We've got slope, we've got a point. Let's figure out what those are like we just did in those other two examples. So the slope is what's in front of the parentheses, so I've got a negative 1/3. The point, the x part of the point is hanging out with x, but I change it to its opposite. So I see a -3, change it to its opposite, +3. I see a -4 hanging out with y, I change it to its opposite, a +4. So now let's graph. You have to graph the point first. So I'm going to plot 3, 4 on my coordinate plane. And then I'm going to use the slope to build other points. So I'm going to go down 1, right 3, down 1, right 3. I'll go up 1, left 3, up 1, left 3. Now remember, we want to go all the way across the plane. I should see points. And then try to connect them to the best of your ability with the straightest line possible. Put arrows on both ends. You're done. So you have to be able to read the equation in order to pull out the important pieces. But once you have that, you guys know how to plot points. You know how to do slope. So you just have to get those pieces taken care of. It's interpreting, it's reading, it's learning what that equation is saying. All right, so if you want to, you can change these to slope-intercept form. Sometimes it gets a little crazy. There end up being a whole lot of fractions. I think these are pretty nice, but you know, you may end up, by doing this, creating a worse problem. It just can happen sometimes. So to change from slope, or from point slope form to slope-intercept form, you're going to distribute the slope, and then you're going to move the constant that's over with the y. And then you're pretty much done. So it's a distributing and then a solving for y. So I'm going to distribute. So I have y minus 4. Let's make that more y. So I have y minus 4 equals negative 1/3 x plus 1/3 times 3 is 1. And then move that constant by adding 4 to both sides. So y equals negative 1/3 x plus 5. And that's it. So you distribute the slope into those parentheses, and then you move the constant that's over with the y, and now it's in slope-intercept form. So let's look at distributing the 2/5. So y plus 5 equals 2/5 x minus 4, and then subtract 5. So y equals 2/5 x minus 9. So if that's easier for you to do than to do the point and the slope, that's fine. But just remember, there might be some weird fractions that pop up where doing the point and then doing the slope might be better. All right, so I'm going to graph these using the point slope form. If you would rather solve for y when you do this work in the homework, you need to make sure you're showing me you're solving for y. So here I'm going to identify my slope and my point. So my slope is -3. My point, I do the opposite of -1 in the x. So there's -1, opposite of -1 is +1. And then over with y, opposite of +1 is -1. So I'm going to plot the point 1, -1. And then I'm going to go down 3, right 1, down 3, right 1. Up 3, left 1, up 3, left 1, up 3, left 1, all the way across the plane with points. Connect them with a line, arrows on both ends. Done. Yay! All right, so number 6. We are going to figure out what our slope is. -2, the point. The x part of the point, opposite of +1 is -1. Opposite of +3 is -3. It's all about opposites, guys. -1, -3 is right there. We're going to up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Oh, man. All right, so I've got -1, -3. I'm going to go down to right one, down to right one. I'm going to go up to the left one, up to the left one, up to left one, up to left one, up to left one. Get our line in there. Arrows on both ends. We're done. Oh yeah. Hey, don't forget, you got to take quiz 2 today. All right. This one gives us not a, it might be a y-intercept. All right, let's look. I'm going to do the point and the slope. Slope is -1/2. The point is the opposite of 0 is still 0, and the opposite of -2 is 2. So, it does give us a y-intercept from time to time. But don't rely on that. I've got down 1, right 2, down 1, right 2, down 1, right 2, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2, and there we go. We got a line. All right, let's look at number 8. The slope is 3/4. The point, the opposite of -3 is +3. The opposite of +2 is -2. So let's plot the point 3, -2. Go up 3, right 4. Go down 3, left 4. Down 3, left 4. And there she is. What a line! All right, so identifying the point and the slope, or you could work on graphing these. But if you look here, like that y-intercept's not going to be that great. So it's one of those things where you might have to estimate, and estimation doesn't necessarily give you the right answer every single time. Okay, so let's write an equation. We're going to use, that's not standard form, we're going to use point slope form. And that is our format, y minus y1 equals m times x minus x1. We're going to use it when you know a rate of change and a pair of values, but not the starting amount. So they give you information, but they don't tell you how things start. So here is our example. A train travels at a rate of 70 miles per hour. They've already told us that's our rate. This is our slope. 2 hours after leaving the station, the train was 210 miles from its destination. So this is going to be our point. 2 hours, 210 miles. The question is it going to be 2, 210, or is it going to be 210, 2? Okay, that's the question. The slope is going to help us. Remember that this is change in y. Slope is change in y over change in x. And we're going to look at the units. So we're looking at miles per hour. So do you see how miles is on the top with y? That means miles is the y part of the point, and hours is on the bottom part with the x. That means 2 hours is the x part of the point. So that means that the point is 2, 210. Looking at your slope will help you, and that's why units are important, and understanding that change in y over change in x. So now I have a point. This is going to be my x1, and this is going to be my y1. I have my m. I'm ready to go. So y minus my y1 is 210 equals m, which is 70, parentheses, x minus my x1, which is 2. That's it. We have it in point slope form. I just went through, I was reading this, y minus y1, and filled in the y part of my point, equals, filled in my slope, parentheses x minus, wrote down the x part of my point. That's all I did. So it's pretty straightforward, and you actually, this is used a lot in calculus. So if you're planning on getting up to the calculus level, this is one of the best ways to write an equation, because they'll say, hey, you want to find this derivative at this point. So they already give you a point. They give you something to help you find the slope. You need to write an equation. You just get those two things together, the point and the slope. You've got an equation, and it's pretty straightforward. All right, so Paul wants to place an ad in the newspaper. One newspaper charges $14 for the first 3 lines, then $2 per line after that. Write an equation that models this situation. So defining our variables, we can use different things. I'm still going to use x and y. Question is, with the information that they give us, can we figure out what a rate is, what a slope is? I feel like these two pieces of information go together. So I think that's the point. This $2 per line, I like that for my slope. Okay, so if I look at my change in y over change in x, and I look at dollars per line, my y is going to be the amount of money or the cost. The x value is going to be the number of lines. Okay, let's write an equation. So y minus, I don't have it here, hang on, y minus y1 equals mx minus x1. That's important to have. So y minus y1. So we need to know the y part of our point. We don't even have a point yet. Let's get our point. It's going to be, let's see, x is the number of lines. So how many lines? First 3 lines, we'll say 3, because that's the number they give us. And then the cost is $14. So I've got the y part of my point now. Y minus 14 equals, my slope is 2, x minus, the x part of my point is 3. There's my equation. All right, for a period of time during Hurricane Irene, rain was falling at an average rate, of 11 inches per hour. Meteorologists stated that after 5 hours, there was 57 inches of rain in the area. Write an equation. So 557, those two pieces, this is my point. Here's my rate, inches per hour. I'm still going to use x and y. Let's think about our slope helping us out. I love doing this. I think that this is so cool. Inches per hour. So that means that y is the number of inches of rain, and x is the number of hours. Okay, so then that means my point needs to be number of hours, 5 hours, comma number of inches of rain, 57. Now, it's possible for them to give you 2 points and you have to find the slope that way. I don't know if you're going to have a word problem like that. You might, but you would just do your y2 minus y1 over x2 minus x1. In this case, all of our examples so far have been giving us actual slopes. So, let me write this down. Y minus y1 equals m times x minus x1. We're going to need that. Y minus my y part of my point is 57 equals, my slope is 11, parentheses, x minus the x part of my point is 5. Here's my equation. All right, so if they give you 2 points, like 2 sets of values, you end up with like 4 numbers floating around. You might have to figure out the slope. And then you might have to figure out this change in y over change in x, which makes sense. Is it people per hour or hours per people? You know, that kind of thing. All right, so then now I just have a plain old algebraic one, no situation involved. So I know my slope, I know my point, x1, y1, and we're just going to use y minus y1 equals m parentheses x minus x1. We're going to set that up. So y minus y1 is 13.5. Notice that it was a positive, but then when I bring it into the equation, it turns into a negative. 1/6 x minus, and my x part of my point is 60. Now, if I was asked to, like in your homework, once I have my point written, asked to solve for y, I would distribute, and then I would end up moving this by adding 13.5 and combining like terms on the other side. So just keep that in mind, because I do think in the homework there's 2 problems where you have to write it in point slope form, and then you have to change it to slope intercept form. All right, let's do another one. Write the equation of a line that has a slope. Here's my m. Here's my point, x1, y1. All right, y minus y1 equals m parentheses x minus x1. Do you know the more that you write your formulas down, the more they'll stick in your head? I think that's pretty cool. Y minus, okay, the y part of my point is -3, equal m -4 x minus 2. Now, right here is something I want to address. You are never going to see minus a negative in like a test question or anything like that. It's going to end up being y plus 3. Okay, so minus a negative changes to addition. So that's where the addition sign comes in. If you're plugging in a negative number, it will turn into a plus. So watch out for that. If you're plugging in positive numbers, it'll turn into a minus. All right, so this one, they give you 2 points. And this is what I was kind of hinting at earlier on. If they give you 2 points and they don't give you slope, you have to find slope. Remember, we did this in lesson 21, figuring out what the slope is. Once you have slope, you can use one of those 2 points to write an equation. So let's figure out our slope. Let's do -7 minus -1 over 6 minus -4. So -7 minus -1 is -7 plus 1, that's -6. 6 plus 4 is 10, so this is -3/5. There's my slope. Now, you have to use 1 point. There are 2 options, so that means that we can have 2 different equations. I'm looking for both. Usually in a multiple choice, you can kind of tell what numbers they've used, but at this point where it's kind of open-ended for your response, either of them are going to work. All right, so what I'm going to do is I'm going to write 2 different equations, equation 1 and equation 2, and they're going to both be the same. So I'm going to do y minus, my y1 for equation 1 is going to be -1, but y minus -1 is going to turn that into a +1, equals, my slope is -3/5. X minus -4 is going to change that into a +4. So that's one of our equations. The second equation is going to look a little bit different. Y minus -7 would make that a +7, equals -3/5 x minus 6. So they look very different. The only thing that they seem to have in common is the slope. But if you give me a second, I'm going to show you that they're the same. So when I solve for y, I get -3/5 x minus 17/5. I get -3/5 x minus 17/5. Now, if you're not sure about the fraction work that I did, you're more than welcome to stick that in a calculator and double check me. But notice that when I solve for y, I get the same equation. So equation 1 and equation 2, written in point slope form, do look different. But when you solve for y, you end up getting the same equation. So it really doesn't matter which point you choose. As long as you choose a point, you plug it in correctly, you make sure your signs are right, your slope is right, then everything should be okay. And it doesn't really matter which point you choose. So let's try another one. All right, let's get our slope. M equals 9 minus 6 over 6 minus -3. 3 over 9 is a third. All right, we get to make a choice. It doesn't matter which one we choose. I'm going to do this one first, but then I'm also going to do this one so that you can see what happens if you chose point 1 versus point 2. So point 1 would look like y minus y1 is 6 equals, my slope is 1/3, x minus a negative 3 would become plus 3. So there's one equation. The second one, y minus y2 or y1 is 9 equals 1/3 x minus 6. They're different. The only thing that they seem to share is the same slope, but they are actually the same equation. All right, especially when you solve for y. So I think that's it. Yep, that's it. So have fun playing with point slope form. It is different. You really, really, really need to have that formula close by. So make sure that you're using it. It's all about plugging the right stuff in the right spots. Don't forget to take your quiz. And don't forget you have a test next week. All right, I'll see you guys later in the next video.